applications. And I am joined by CTO of Ample, Taylor McDonald. Uh, Taylor, thanks for being here.
Yeah, thank you so much for having me.
All right, so there's you built a demo over the last couple of weeks that showcases RAG application using Netlify DB, and I want to dig into that specific example soon. But I think a lot of us who have played in this AI space or are new to it, we come across this term RAG, but don't necessarily know what it means or what it does. So maybe you could start us off with a quick little intro of what the heck is RAG.
Sure. Yeah. So RAG is just an acronym that stands for Retrieval Augmented Generation. And so it's kind of a fancy term for basically saying you're going to augment the generated responses that you get back from an LLM. So think ChatGPT or Claude or any of these large language models that you might be working with. The real power and benefit of using those tools is that they're giving you sensible responses to natural language queries. One thing I found great is I've been less sensitive to like typos when I'm talking to ChatGPT because it can kind of infer the intent and can sort of unpack what you're asking for and still give you an intelligent response without, getting tripped up on a typo or something like that. Well, the benefit of RAG is you're basically saying, hey, ChatGPT, when you ask it a question, you're handing it context based on information that you have at your disposal. So in our case, we do a lot of client work. They have a lot of our clients have, discrete sets of data or different information in their database. Maybe it's, like their CMS and they've got a knowledge base in there, or perhaps it's like support documentation for an internal support team that's fielding questions via phone calls and stuff like that. What we can do is we can take that information and we can search through that before we ask ChatGPT to answer the question. And we can say, here's a whole bunch of information that is contextually relevant to the user's query. And then you're effectively saying, like, here's the query for the LLM, and here's a bunch of context to help you answer this question. And then ChatGPT can kind of make sense of the context you've provided and give an intelligent, rational response that's sort of couched in the content that you handed to it. Pretty powerful pattern.
So you see it most of the time, it's going to be embedded in some sort of application that is trying to do something specific, around some particular context.
Yeah, so a lot of our clients, when these LLMs started exploding on the scenes, it's like this is great and it's so intelligent, but it's not grounded in any sort of like my own data set. And then of course there's privacy concerns. LLMs can also hallucinate, so sometimes they'll just make up random stuff, and you're like, where did that come from? The RAG pattern is actually a really great solution to reduce some of those hallucinations and make sure that you're only requesting responses that has been informed by data that you control. So rather than go out to the open web and try to solve some problem or answer some random question based on everything it knows, you're effectively saying, here's what I know. Here's sources of information to answer the question the user's asking about. In that case, it's your client's data or what's in your CMS or what's in your knowledge base, that kind of thing. And the LLM can just use that as its data source. And you can even give the LLM additional information like, hey, if you cannot find the answer inside the context that I've provided you, just tell me you don't know the answer and don't go make something up.
Okay, this makes sense. Yeah, I mean, and in your world, you're running an agency, so you're working with lots of clients, building lots of apps and websites. Where do you see it being most applicable to you?
Um, uh, so currently, most of our clients are interested in just reducing the amount of time around either client support. So we've got a client that does, really complicated engineering projects, and they have civil engineers on staff, so that the contractors, as they're installing some of these products, might call in and say, "Hey, it turns out this type of soil I'm trying to install this in is different than what I expected, or I'm trying to figure out this dimensional problem, or whatever." The idea would be that you could effectively reduce the amount of time spent amassing the responses on behalf of the civil engineers, so they could theoretically like go query, like, here's the user's question, and we can go mine all that information out of data that they have available, but you're just kind of reducing the amount of time spent amassing that information and giving that back to the civil engineer, who is then now armed with real clear specifics. Another cool aspect of this is you can seed actual sourcing information. So you could say, here's the answer to the response, and then here's a link to that particular document that contains the answer. This is where I found that piece of information. And then, of course, you give that back to the user and they can peruse that. one of the biggest benefits here is this increases confidence and trust on behalf of that system. So everybody is completely enamored by what these LLM systems can do. But if you're worried about either data privacy, you're worried about hallucinations or something like that, that can kind of erode some of that trust and make you less likely to feel confident that the responses you're getting back are grounded in fact and reality. But in using this particular pattern, you can kind of eliminate that, and you can provide the source information directly to the document or the record or the CMS entry or whatever it was that provided the grounding information and factual basis for the response coming back from the LLM.
Okay. Yeah, I could see. I mean, so much potential just to be able to set that context and um, like if you're just using Chat GPTs, you can still give it context, but you have to you basically have to type that in every time, essentially, right? Like this
Correct.
sounds like you can source from a dynamic source, and but so your context can change based on user input without necessarily needing to manually put that in.
Yeah, absolutely. And you can start stringing together all sorts of workflows, right? So if you
Mm-hmm.
have a RAG pipeline, imagine your marketing team is publishing new thought leadership posts every week. You could set up a CI integration so that you're notified when a new post goes up. You automatically ingest that content, put it into a separate like vector database. And then when the user comes along and is querying, they're getting real up to date insights based on all of the newest content that was published to your system. You could take it a step further too. You could even use the LLM to determine the value of that response or the relevancy of the data that's being returned. And let's say that the user's asking a query that doesn't exactly match some of that stuff. You could string that into more of an agentic workflow to say, hey, it turns out these responses don't seem particularly relevant for the user, so let's go out and we'll do some additional research online, or perhaps there's other APIs that you want to tap into. You can start stitching all these things together where, I know we're talking about RAG today, but this is really the foundational like beginning of building a front end that is informed with your data. And then you can start, manipulating and curating that in a manner that makes sense for your use case.
Yes, I love that. There's so much power in that. So let's take a look at your example. Can you
So
kind of walk us through what it is, how it works, and I might have specific questions from there.
yeah, of course. So I guess we'll just start on the front end here. Can you see that okay?
Yes. Yep. Got it.
Okay, so this is obviously like this is all sort of described here in this document that was just launched on the Netlify Dev Hub. And so you can kind of walk through both the thought process and explanation of what RAG is, what are the different kind of dependencies and competencies you need in order to get going, and then an actual real world example of taking some data. In this case, it's just kind of generic data, and then ultimately this is what the front end looks like. So what we ended up building here was a kind of a travel guide for San Francisco visitors. So if you're traveling to San Francisco or something like that, maybe you're looking for a place to eat, you're looking for a place to take your kids, you want to go take a hike that afternoon or something like this. The idea would be this is some sort of like, front end LLM powered, application that you could say, hey, where should I get mussels today or something like that, and hopefully it would return a relevant response based on that query. The application itself doesn't require you, or the tutorial, if you were going to walk through this, it doesn't actually require you to have this field. To make this publicly accessible, we figured it might be simpler to just have you bring your own API key. So I'm just going to copy one to my clipboard and paste it in here. Once it's pasted in, that API key will last for the duration of your session using the app. So it's not super annoying. You don't have to paste it in every single time you ask a question. But for example, if we were going to query the RAG pipeline here, we might say, what is a good place for dinner tonight? And so what it's really doing right now is the application is creating a similarity search against information that we have in our database that have been embedded through this, vector process that is outlined in that tutorial. And then it's taking the information that's returned as context and handing that off to the LLM. So the LLM is what's really interpreting my question. And then based on the context provided, it comes back with a natural language response. In this case, it recommended a place called Morad in Soma for contemporary Moroccan cuisine, or perhaps Benu. Sorry, I'm not from San Francisco, so don't judge me. too much. But anyway, you get the idea. So like it's pretty cool. You could even, you can ask anything like, where can I take my kids this afternoon? And hopefully it comes back with something reasonable. Yeah, it says you can take your kids to Dolores Park this afternoon, sunny spot where families gather and you can enjoy a picnic, watch colorful sunsets behind the city skyline. So pretty powerful. In terms of like what's actually happening in the back end. So what we ended up doing to kind of simulate the process of chunks. Let me back up. When you have a whole big document or a big data set that you want to make available to your RAG application, you're going to want to break that into these small digestible chunks. There's reasons for this, some of which are like the cost implications of sending a massive amount of context to the LLM when you're querying it. But moreover, this helps kind of keep everything both cost effective, but also within what is called a context window for the LLM. And so for the purposes of this tutorial, and you can link to all these files, what I did was I generated 100 markdown files that just had interesting information about restaurants or activities, different neighborhoods and things like that in and around the San Francisco area. And so this would be an example of the markdown file. Now I intentionally sort of kept them small because I wanted to simulate what a traditional chunk size would be. But if you were going to do this on your own, let's say you had a 2,000 word white paper on some topic for your client, you would want to break those into manageable chunks. And the idea of those chunks are that you want to give enough context to the LLM to be able to answer the question, and then enough appropriate overlap between the different chunks so that it can find relevancy and then determine, what the sourcing information would be before you send it off to that API. So in this case, we've already kind of like created the chunks, but effectively there's a multi-step process where you chunk your data, you put it into the database, and then you are querying against the vector representation, which is just this big numerical representation of that data. So once you have your chunks defined, you can send each one of those chunks to the embeddings API or similar for your language model. And you can say, I want you to create what's called a high dimensional vector representation of this content. It's really just an array of these numbers. I'm not smart enough to fully understand how all this stuff works. Just know that there's an endpoint you pass your text to, and what you get back is a whole bunch of numbers. You put that into this column here, this embedding column. And then when the user conducts a search, what you're really doing is you're creating a vector representation of that search. And then you can use like a cosine function in your SQL query against that database to say, give me all the rows that are closely or similar to what the user asked. What comes back will be, 5 or 10 rows of information. And then that becomes the context that you pass off to the LLM. Let me stop there because I know I'm moving pretty
So
fast.
you basically have two layers of the process as well. So you're taking the question in, and then you're pointing the LLM to the entire data set first, and then finding the subset.
No, it's actually the first thing you do, it's just like a traditional SQL query, right? So if I say, where can I take my dog to the beach? Right in that moment, what the application did was it took where can I take my dog to the beach, and it created an embedding or a vector representation of that query.
Okay.
Then we do just a straight up SQL query, and I can even show you here. Um, it's here's the example of the SQL query I'm using in this app. So it's literally just saying, hey, select the content where the embedding in the database matches the embedding or is similar in to the embedding that I generated on behalf of the user, and then just return all of those, and then you can limit it to the number of responses you want back. Once you get that information back, it's going to return. So this is what that query would return. It would basically be like, here's your result set. In this particular example, it's showing 3 results that are similar to this query, which is where should I eat dinner? This array is your context, right? And so then the next thing you do is you basically just package that up. And so here is the kind of query you're making against ChatGPT, and I'm using the GPT 3.5 Turbo model, but you can use whatever you want. But effectively, I'm just inserting that context directly into the query before it goes back. Pardon me, my dog seems to be barking. Told you she
Very
did.
excited about this. Okay, so yeah, this makes a lot of sense, and I'm already dreaming up ways that I want to build something out for me But let's can you talk again about that, the chunking process? So if this was really like, rather than you shoving the markdown that you've generated into the database, but it was more like, let's say you were going to source comments from a travel website about um, restaurants in a neighborhood, or something like that, then, and you can't control, whatever the situation is, you can't control the length of what that content and what the content would be.
Right.
Would you still would you chunk the data before you store it in the database, or is it something you do as
Yes.
you're pulling it out? Yeah, these you would. Okay.
Yeah, so that's a great question. So I'll give you an example that we've done for one of our clients where they had a 300-page PDF. Obviously, tons of data, way more than you would be able to put into any one representation, at least not performantly. So what we did was we read that PDF into memory, and we wrote a little bit of function that would basically like chunk it into usable values, right? And you're kind of trying to align this between like 500 and 1,000 tokens, right? And so I'm not entirely sure what that math looks like, but you can kind of play with it a little bit. And obviously, like ChatGPT or Cursor or Windsurf or whatever you're using for your vibe coding today could certainly help you with this. Just say, hey, write me a function that can chunk this content into appropriately sized chunks for a vector database. And then what it'll do is it'll just spit back like an array, So if there's 10,000 words in that text, it'll just bring back, you know 200 little array options, which just represent little
Mm,
strings of the larger document. Then you just loop over that array, and as I mentioned, you call the embeddings API to generate that string representation, or the numerical representation of that string. And then that goes into the database, and then you can, then at that moment, you've got your chunks, everything's good. The only impact to the LLM is you asked it to vectorize the string. Um, User makes a query, you conduct a similarity search against your own data set, and what comes back is a subset of those chunks. So here's 5 chunks that are relevant to what the user searched, or at least it's what I think is relevant. And then you can pass all of that off into your prompt. So your prompt would be like, where do I take my dog to the beach? And then you add the context right there in the prompt, and you say, here's the context that I want you to respond to this query with. And then the LLM kind of reads it all in and figures out what an intelligent response is based on the data you gave it.
that makes sense. Okay. And I think, I was one thing that I'm still blown away, even after I've read through the guide, and it's, it just in a few steps, you've got this incredibly powerful tool at your disposal. And I noticed you're using Neon, and we recently launched Netlify DB, which wraps Neon but doesn't require you to have an account there. And so you've got just this really simple um, Vite front end using Netlify function for the back, or for the server side bits, and then Netlify DB, which is Neon,
Yeah,
for the data. So it's kind of amazing that you're running a few commands, and then you've got this thing up and running. So that's why I'm thinking, oh man, I can apply this to so many different little applications
totally.
that I want to spin up.
Totally. I think for the engineers on my team, I think there's been a lot of confusion trying to get our heads around the entire ecosystem. What do you actually need? There's all sorts of like marketed as like straight up AI ready vector databases and Weaviate and Pinecone and things like this. And those are obviously really valuable services in their own right. Once I realized that you could use just a simple extension. So if you're familiar with Postgres, a lot of our engineers have been using it for years, and you understand all the different bells and whistles, and how, the syntax is obviously very familiar and things like that, that all you have to do is implement the PG vector extension, and you can immediately create a table in your normal familiar database environment that can store this information. And then you can, when you create that extension, or you enable that extension, you can start now querying stuff against those vector you can use specific functions and features that allow you to do that similarity cosine matching. So the PG vector extension unlocks all sorts of power for any just vanilla Postgres database. I mean, you can do this on your local machine if you wanted to. No big deal, no cost included. So that is super powerful. And then in terms of the rest of the workflow, I mean, Netlify is incredible in the different toolings that they offer. To your point, the Netlify DB is a one-click kind of command that can provision that database for you, get everything stood up. Then in tandem with the Netlify CLI tool for generating and running this, one particular thing that I found really powerful is using the Netlify project interface to store my environment variables, and then I'm consuming those through the Netlify CLI tool and making those available. And in fact, in the tutorial, it even kind of outlines a way to execute binary commands that are defined in my local project through the Netlify CLI context, so that we can automatically ingest a lot of those environment variables. So it's actually great. And if you walk through that tutorial step by step, you'll see the power of the ecosystem that you guys have developed. I mean, it really kind of puts all these pieces together, and it results in this really great developer experience, for the engineer on my side. Just kind of stitch it together and you're up and running in maybe 20 minutes. It's unbelievably powerful.
And so it sounds like you've already explored ways that you can use this for your clients. Have you thought about, are there things that you can build even just as internal tooling for Ample that would help your business or your workflows or anything like that?
It's funny you mentioned that. So yeah, as a matter of fact, what we're currently exploring is an opportunity to build a machine learning pipeline that can kind of stitch itself together to all of this, right?
Mhm.
So ingest content that's specific to the client through this RAG kind of pattern. And then what we're considering is building like a machine learning model that can basically make predictive analysis based on the data that we have available to us. So it sort of stitches together all of these different worlds. And then, on top of it, you guys have been doing a ton of work on MCP servers and stuff like that. I mean, it just the way I think about this is there's so much opportunity. It's almost like we're right at the precipice of this amazing new ecosystem of tooling and connections, and the fabric of these applications are changing by the day. And it's so amazing that and we have a litany of opportunities and features that we want to build and things that we want to bring to our clients, or to your point, our internal team, generating things like discovery or deep research clones that can, figure out, the nuances of this particular industry or this particular market or this particular challenge. And when you couple all that together with things like predictive analysis and so forth, I mean, it is really exciting and super powerful kind of ecosystem of tools. So yeah, we're really, really looking forward to the future. There's tons of really neat applications.
Yeah, I mean it's the Wild West out there, but it does feel like you gotta jump on it now. I mean, if you can get the handle on it, things are just they're changing so fast, but it's super interesting.
Yeah, I completely agree.
Well, Taylor, I really appreciate you having a chat with us today and taking us through this application and folks out there, go to developers.netlify.com to find that DevHub guide and work through the tutorial.
Awesome. Thanks, Sean. Appreciate it.
Thank you. All right, folks, that's it for today. I'm going to be back here on Friday looks like it's going to be 12:30 Eastern time in the US, and we're going to talk all about styling your AI generated applications at that time. So have a good one, and I will see you here next time.